vine, actually, initially inclined at an angle of 37.0 with the vertical. What is his speed at the bottom of the swing if he does the following? A starts from rest, and B starts with the initial speed of 4.0 meters per second. So, I'm going to draw this out. This is my vertical. Now, let's pretend that that is the vine as well. And this is the vine at rest. And at rest, Tarzan would be down here like this at his lowest possible position. I think about this as a radius of a circle. Because when you're swinging along the circumference of the circle, and the vine is going to end up being the radius. So if I end up pulling back the vine to 37 degrees, if I can draw a perfect circle, the radius would be the same of 30.0 meters. This is going to be pulled back at 37 degrees. But notice that Tarzan is now, here's Tarzan. Tarzan is now this high off the ground. And that's your height. So the vine actually turns into the hypotenuse of a right triangle. And my goal is, to find the height Tarzan will be when that vine is pulled back 37 degrees. So I got to find this height, because that height is going to dictate the potential energy at that moment in time.
Is that from the speed?
I put it from the center of mass belly button. Not that it matters all that much. So I look here and I realize, all right, I've created a right triangle. Hypotenuse is 30. I can find this side if I know this whole entire length is also 30, because this would be the length of the vine at the neutral position. I can subtract 30 minus this side of the right triangle to get the height. That kind of makes sense. So, here's the side I want to find. Let's call this the adjacent side, because I notice the side is adjacent to my angle, which will lead me to use which trig function? Cosine. So I can say that A, and I just call this letter A for the adjacent side, is 30 cosine 30.0 cosine 37.0 degrees. So what I can do here is type this into the calculator. Make sure if I give you a question like this tomorrow, Monday, the calculator is in degrees, not radians. And you get 23.95, which rounds to 24.0 meters. So if this is 24 meters here, and the whole thing is 30, how high is Tarzan off the ground? It's going to be 6, because this whole thing is 30. That would be when the vine is at its neutral position, minus this amount, which is 24. So the height Tarzan is off the ground is 6.0 meters.
How did you know it was frozen?
Because the side I want to find is this one right here, and it's adjacent to the 37.
So if it was sine, it would be
This one, and I care less about this side. All right. So all of that being said, this is a law of conservation of mechanical energy problem. So the KE initial plus the PE initial will equal the KE final plus the PE final. At this point in time, I can cancel some stuff out. On the left side of the equation, which one of those energies do I have nothing to start? Because he's being pulled back, and so it's right before he starts to swing. And since it's right before he starts to swing, he's temporarily not moving, so KD cancels out. How about on this side of the equation? So Grace says that the PE cancels out because when Tarzan comes through at the lowest part of his swing, it's all kinetic, no potential. So I'm going to spell this out here. MGH equals 1/2 mv squared. What cancels? Yep. Mass cancels. And my goal is to find this velocity, so I can multiply both sides by 2 and square root. So I'll end up with the square root of 2gh equals the velocity. Now, and that looks a lot like what happens when you find final velocity from UELM number 5. 6.0 is your height. And when I solve this out, I get 10.8. However, I've got 2 sig figs in the height, so it's 11 meters per second. That is going to be part A for this particular problem. Miss Grace.
How did you get 6 meters for the height?
Okay. So here's my swing, right?
Yeah.
So it's swinging back and forth, radius of a circle, correct? So if I pull it back and imagine Tarzan at the end of the swing, pull it back this far, you notice that he is now not at its lowest point, right? So the height that he's off the ground changes. Now, if I know this is 30, I know this is 30, I can make this into a right triangle, find the long leg, subtract it from 30, and get that height.
Oh, okay.
Yes, sir.
So is PE after 0?
Because he is, like when you're on a swing set, you swing through, you are not stopped at that point, you have all motion, no potential energy.
Okay, so that PE after goes at the bottom.
Yes,
That's the KEI?
that's kinetic energy final, because you want to find the velocity when he's at the bottom of this swing. I don't remember what homework problem this was from. It was the mechanical energy video and problem set. I know it's in your notebook somewhere. So if you want to retrace your steps on that one from a couple of weeks ago, and this helps. So, for part B, I'm going to erase this again, because I have less in part B that cancels out. Part B says Tarzan is going to actually have an initial velocity of 4 meters per second. So at this point here, he must have started from up here, because at this point, he now has an initial velocity of 4 meters per second. So, looking at this equation, since he now has an initial velocity, what is the only type of energy that cancels out? Final potential energy is the only thing that cancels out there. So, because of that, I write out 1/2 mvi squared plus mgh equals 1/2 mvf squared. Equation for kinetic energy is half times mass times velocity squared. Equation for potential energy is mgh, mass, gravity, height. What cancels? Boom, boom, boom. So same process here. I can't cancel out this half because this doesn't have a half in front. But I can multiply both sides by 2. So this turns into VI squared plus 2GH equals VF squared. What does that look like? Number 5. Exactly. All connected. And now I'm ready to square root both sides and then plug in my numbers. So I'll get 4 squared, which is 16, plus 2 times 9.8 times 6.0. Square root all that stuff. And there is 3 sig figs in this velocity. There's only 2 sig figs here. I just figured out I got sig fig error. So it should have 2 sig figs, so this should actually be 12 meters per second. So there should be 2 sig figs in that one. Yes?
Does he on the left side you have 2?
I'm listening.
You have 2 M's crossed out. On the right side you have 1 M crossed out.
Well, M is common in all 3 expressions, right?
Right.
So if I have a variable in all 3 expressions, I got an M here, I got an M here, and I got an M here, that means I can cancel all the M's out. Divide everything by M.
Even though it's not, even though there's more M's on one side than the other.
Yeah,
Okay.
for sure. The only time I can't cancel, like in the last problem, is if they all don't have M's. So if 2 of them have M's and 1 of them doesn't, then I can't
Oh,
cancel.
but all 3 portions of M's.
Yes.
Okay, so it's not what side is the equal bar.
Yeah, it'd be like doing this. So if I divide this all by 4, it'll all be the same answer.
Like 4 times 2 is 8, 4 times 8 is 32, that's not.
Well, I'm just giving you an example. I'm giving you an example where I can cancel things out. If you got a variable in common in all the expressions, all of them cancel out. Okay. What was next? Number 10.